Hello friends, welcome to my YouTube channel. Today we are going to discuss feedback amplifiers. Feedback amplifier is one in which fraction of amplified output is fed back to the input circuit. Feedback amplifier, see here, consists of two blocks or two components. First one is basic amplifier and a feedback network. Here you can see output is sampled and given to the feedback network, and output of feedback network is mixed with external input over here. So this is a basic block diagram of feedback amplifier. Now before we proceed further, let's discuss two types of feedback: positive feedback, which is used in oscillators, and negative feedback, which are used in amplifier circuit. Now in positive feedback, this signal Vs and Vf will be in phase with each other, and for negative feedback, Vs and Vf will be out of phase with each other by 180 degree. Now let's define few terms over here. Let's say A is the gain of amplifier. Remember, it's without feedback. AF is a gain of amplifier with feedback, and beta is a gain of this feedback network. So gain of feedback network is beta. Just don't confuse with beta of transistor, where beta is the current gain. This beta is gain of feedback network, or it is also known as feedback factor, not amplifier, feedback network. Now due to negative feedback over here, V in this voltage over here, V in is Vs minus Vf. V in is Vs minus Vf. Now put the value of Vf in term of beta and Vi in term of Vo and A. When I solve this two equations, I get this value. AF is A upon 1 plus A beta. So I can say gain has decreased by this factor, A 1 plus A beta. Remember this factor. This factor is very important in negative feedback analysis. Now let's discuss the advantages. First advantage is gain stability, because the feedback gain with feedback is given by this formula, and this A plus beta, 1 plus A into beta, is far greater than 1. So I can approximate it to A beta. When I approximate it, I get AF depends on 1 by beta. That means it is independent of transistor parameter. Since you know transistor parameter varies with temperature and other factors, therefore overall gain of amplifier is stabilized. Now there is an improvement in input impedance and output impedance, and that improvement is by the same factor, 1 plus A beta. Just remember that this improvement depends upon type of negative feedback you select. Noise is reduced by same factor. Again, nonlinear distortion is also reduced by same factor. Now bandwidth increases. Now you know gain has decreased, so this upper graph is a gain without feedback. With feedback, gain has reduced to this level. When gain has reduced, here you see cutoff frequencies. First case it is FL and FH. Now here you see when gain has reduced, FL has decreased and FH has increased, and this change is again controlled by the same factors. So you can say overall bandwidth also increases by this factor. Now there are few drawbacks or disadvantages. First is gain reduces by this factor. Second is it's difficult to implement this type of circuit and even more difficult to analyze them. Thank you.